Hello everyone, my name is Laura Ivanciu. I am from the Basic of Electronics Department, Technical University of Cluj-Napoca, Romania. My presentation today will be about focus level estimation using AI and multimodal sensor fusion, current trends and research opportunities. As a brief introduction, we all know that we spend so much time in front of screens, phone screens, computer screens, laptops, and so on, be it for online learning, meetings, work-related activities, and even when we're done with work, we choose maybe a bigger screen for relaxation. This leads to a decreased average attention span, which is now as low as 9 seconds. This influences the time we need to properly learn, to properly acquire knowledge. It's getting more and more difficult to stay focused, and our efficiency and productivity are significantly reduced. So what can we do about it? Depends on which perspective we are working with. From my perspective as a professor in the university, when we were obligated to hold our classes online, I tried to produce more engaging content for my students. If I'm in a learning environment and I myself am the student or I'm trying to work, I need to take regular breaks to keep my focus levels at an optimum value. Today we will be discussing about methods to measure, to monitor, to assess focus and attention levels and why they are important. So why are they important? Why should we monitor focus or attention levels? Well, attention is a key factor in everything we do. Even if we want to learn, even if we're in a work environment where we have to make decisions, we want to have a high productivity as possible. There are some challenges when we're assessing our attention or focus. As always with self-assessment, there is the bias we cannot get rid of, and these self-reports can often be unreliable. Additionally, external factors can greatly influence our focus levels, distractions, other colleagues, notifications from your phone, or a bad day, for instance, an emotional state, fatigue. These all can lead to a decrease in our focus and attention levels. The idea is to monitor these levels using automatic methods. This means getting rid of self-assessing, self-reports. And these methods should combine various types of inputs because we now have access to, or through cameras, through sensors, we have access to various types of data. Typical applications for monitoring focus levels can be in online education, remote work environments, driver monitoring, productivity tools. I will discuss these later on. The Gallup report shows us that not only it's interesting to monitor focus levels, but this has a great importance in the working environment because as low as 23% of employees are currently fully engaged in what they do, meaning they pay attention to their tasks, they try to maintain a high level of productivity, whereas 15% are actively disengaged, not interested at all in what they're doing, and 62% are somewhere in the middle, not engaged. These values can be an indicator of silent quitting, where employees do the bare minimum before they quit their jobs. Even if the level of engagement is on an increasing trend, as you can see here from 2010 to 2023, 2024, even if it's an increasing trend, it's still not big enough. So it would be useful to have tools that monitor focus level for the employees, and alerts can be sent when certain level is reached. Some typical methods to monitor focus levels. As I mentioned before, multimodal sensor fusion gathers and combines various types of data. This data can be obtained from cameras, where we make a visual assessment. We detect emotions from the face of the subject, we detect the head pose, we detect the tilt of the head in relation to the screen. Physiological signals such as EEG and GSR, galvanic skin response, and also environmental factors which can influence our focus level. Environmental factors such as noise, ambient light, ambient temperature. Uh, what role does AI play in all of this? Well, with the help of AI, it's much easier to combine all these different kind of data and provide an accurate classification or estimation of the focus level by using either deep learning models designed from scratch or pre-trained models such as ResNet or EfficientNet. Mostly AI is used to analyze images, facial expressions, to track the gaze, to detect drowsiness, to count the blinks per minute. The idea is to combine the information we get from sensors with image analysis, and this we can get an accurate estimation of the focus level. Current trend. Fortunately, people love wearing devices that measure their physiological parameters. The global wearable technology market, as you can see from this diagram, is on an increasing trend. A lot of money are being spent on designing and acquiring wearable technologies such as smartwatches, fitness trackers. People love to have their physiological signals tracked and stored and analyzed. On the other hand, high-resolution cameras are now used or can be used and included in, I don't know, a laptop, a computer, or added to a computer, so that we can, in real time, acquire a high-quality image and, based on it, detect the or use that information to correctly assess the focus level. And for sure, all these wearable technologies are based on sensors that are non-invasive. So we want to obtain those signals, those biological signals, with as little invasion as possible, without this discomfort, any discomfort for the one who's wearing it. With AI, we can use deep learning models, convolutional neural networks, recurrent neural networks to analyze such data. And as previously mentioned, we don't need to start from scratch. We can always take some pre-trained models which are publicly available, and some of which were especially designed to analyze facial features, to detect emotions, or to estimate the gaze. When it comes to data fusion, the trend is towards hybrid methods, meaning we read the information from the sensors, we do a real-time estimation, we also analyze features, and we combine everything with AI to obtain an accurate result. Some data sets that are currently in use: the dataset for emotion analysis using physiological signals, the SEED dataset, the MANOB HCI dataset. All these include images and or video recordings together with physiological signals. And these datasets are, as I said, are publicly available by request, and they were used to train large deep learning models. I prepared two case studies to show you some typical applications of focus estimation. One of them is in online education based on facial and physiological data. The student has a headband which detects, measures the EEG. The student is in front of a computer or a laptop which has a webcam. Based on the image gathered from the webcam, it's the face of the student is detected, and this is processed using 3 subsystems: landmark detector, head pose estimator, and facial expressions, together with eye blink detector. So first of all, from the face, we detect the eyes. Then the system counts and detects the number of eye blinks, together with the results from the other 3 subsystems. These all enter a weighted sum block, and the final value is compared to a certain threshold. And if the value is lower than the threshold, this means a low focus or attention level. The simulations for this or the tests for this system showed that a multimodal approach outperforms the unimodal approaches. So the blue line is what we should be following. This rock curve shows that the multimodal approach is best, and we also see here with the values of the accuracy. A second example or second case study, focus estimation for driver behavior monitoring system. In this system, the driver, the image of the driver is analyzed, and this enters a falsification block, which further goes into a feature extraction part, which is actually a convolutional neural network with its typical layers: convolutional layer, ReLU, and max pooling. The features are extracted, and then based on those features, the result of the classification is in one of 5 possible classes. So the driver can be dozing or in a normal state or behavior, talking on the phone, smoking, or yawning. Some of these are actually dangerous when driving. This proposed system is compared to other existing implementations, and we see here that the top 1 and top 5 accuracies outperform some other approaches. And from the normalized confusion matrix, we can see that the true positive rates are really high, so encouraging results. Finally, some challenges and limitations of existing methods. As always, when we're talking about acquiring images or sensor data from human subjects, there's always the issue of privacy and how we were gathering this data. Whenever we're using neural networks, deep learning methods, deep learning models, the computational complexity is always an issue, and the diversity of the databases used to train the model can also be a limitation. Let's not leave aside the ethical aspects. As with any AI system, the system is only as good as the data set it was trained on, so there will always be a bias. For image and sensor-based monitoring, we need consent of the subjects that are analyzed, and this also leads us once again to data privacy. Typical applications for such monitoring focus level systems are in education, where the instructor or the teacher would be greatly helped by something that will show him or her when the students are not paying attention. Because in online classes, students often choose to work with their cameras off, so the teacher cannot see what they are doing. With such a system, even if the data stream is not seen by the instructor or the teacher, it's enough if we get an alarm and we say, okay, these students are not paying enough attention, do something, and then we can really do something, and we can improve our methods. Further on, we can design new teaching methods to that can be used when we have access to real-time focus levels. In a workplace, in our daily lives, whenever we're using the computer, when we're in front of the screen, it's so easy to lose focus, and productivity would greatly benefit if some focus level monitors were added, so that distractions can be reduced, efficiency can be improved, and with this to be able to optimize and design adaptive workflows. Also, in healthcare, such systems will or can be used for early detection of attention or cognitive disorders such as ADHD, or to monitor patients that are during therapy. Finally, in driver assistance systems, using focus monitoring tool would ensure the driver stays alert, and when the focus level drops under a certain threshold, alarms can be issued, even I don't know, some vibrations on the screen or something to wake up the driver and bring their focus back to normal levels. Finally, to conclude my presentation, I think it was obvious enough that focus level monitoring is a task that combines multiple fields. It's an interdisciplinary topic. When we use AI to analyze multimodal sensor data, the results are better than using separate technologies. Fortunately, people like wearing devices that measure their physiological signals, so this helps the data acquisition process. Typical limitations come from computational costs, lack of diversity in databases, and data privacy. Finally, as research opportunities, which I am also following in my current research activities, we're trying to develop a focus level estimation system that provides real-time values with low complexity, with low to none invasion of privacy, and with an increased accuracy. Thank you so much for your attention. I'm now open for your questions.